Hello, and welcome to this section on testing our attribute node. Essentially, we're going to try and test all the functionality in one module. But again, as it expands, again, like I said, I've got quite a lot more functionality in my full version that I use for my work. But you can, again, just keep these in one module if it feels logical for you. I'd say in the future, though, if you keep on expanding out the attributes and you keep on giving yourself more and more functionality, maybe make sure you then break it down into general functionality. You've got the arithmetic operators, the logical operators, comparison operators. Make sure that you break them all down into these subsections. But okay, let's get started. So first we're going to open up a nodal folder, go into tests. Let's open up base as well. And we are just going to essentially create a new test within here. So we're going to right click on tests, go new, and Python file. We're going to call this test attributes. Perfect. Okay, now the next step we're going to look at is opening up the DAG node. And we are going to essentially just copy in this code here. And we will copy that over to our test attributes scene. And just change the information in there to attributes. Okay, now what we also need, we're actually going to create a base class as well. Let's copy that out. Let's steal out the if name is main. Let's put that in. Scroll all the way to the top now of our test DAG node, and let's copy over this test DAG node base here. I'm going to call this test attribute base. Test attributes base. And save. Okay, one thing we should actually do, let's highlight our class and our running code at the bottom, and then just press Control and forward shift just to comment all of that code out. Because what we want to do is we want to test that all of our functionality is actually still running since we, even before we made this, just so we can fix anything before we go ahead and start testing our new functionality. So let's open up Maya and let's click test. 66 tests, ran in half a second perfectly. Great, that's exactly what we wanted to see. Okay, let's close Maya. Let's uncomment by pressing Control forward slash again. Okay, and what are we going to do here? Let's essentially we're going to start off. We're going to need, I say 3 items because we're actually doing lots of comparison. So we can have 3 items. We can have one. Actually, I'll build it first, and we'll come back to this. So let's go ahead and just start running in our code, and then I will run through it in a moment. Okay, perfect. So what have we got here? We've got our setup, and what we're going to do is have an attribute for attrs in case we need to call them later on or cycle through them for any reason. Especially for testing, we can test then each attr. But what we're going to create is our sphere geo, cube geo, and plane geo. Let's make sure actually I have the default name for plane. Plane name. Okay, let's copy that over. And there we go. We can always then assert the name if needed. Okay. And what we're doing this for is because what we want to do is we want to have our sphere, and we want to have that set to all 1 within the attributes, translate and rotate. So all of those attributes now will be set to 1. And within CubeGeo, we're going to set all those attributes to 2. But within our polyplane, we just have everything still zeroed out. It's created at world 0. So what we can do then is check how everything's being plugged in and check the output within polyplane, or within our polyplane. But that's perfect. Okay, now let's create our teardown method. Okay, and then because we're not really focusing on renaming any of these objects at the minute, that's all being tested within DAG and within DEP. We're going to focus on essentially is all nodal connections or attribute connections via our nodal system. So what we can do is just not even assert if these are true, just go through them and delete them all, which we're deleting the offset for the Cuban sphere because they have offset, so we can check essentially against a few other things. And then we've got just a plane, which is not grouped. Okay, perfect. Now we just need our two classes. Let's actually go ahead first and now go over to our attribute base. Select the first def and then hold down Alt and J. Just cycle through all of the functions. Press Control C. Sorry, what am I doing? Press the right arrow to go across, then press Control Shift, and then the right arrow to highlight, then press Copy, then go back to Test Attributes. We're going to jump down here, and then we are going to press Control and V. And so your cursor should be by delete. If you click your cursor to the beginning of delete, double tap Control, and then just let PyCharm not wake up. There we go. And double tap Control, and then keep on pressing up until you're at the beginning. What we're going to do now is write in def test underscore. Are we doing uppercase? Let's have a quick check. What were we doing in test base? Were we doing uppercase for the test DAG? Sorry, on all of our sub items. No, we're just doing it lowercase, so we'll just do it lowercase here. So test attributes. Make sure it's spelled right. Okay, and then an underscore, because not every item will be a done method. What we can do is just select the 3 underscores and then press Control J, hold that down again, go to the beginning, and then just press delete so we don't have 3 underscores. I feel like that is excessive. But now, where we get our second init, that'll be a different class test. We're going to actually just delete the init, so highlight all of that. And then press Enter just to separate a little bit. What we are going to do is, because we're testing attributes here, that is our test attributes class, we are now going to remove the S from down here, double tap Control again. It doesn't like doing that first time, does it? It's one of the only problems that I have. All the way down to delete, and then just delete the S from all of those items. Okay, and now we will Control to the end. Should have already done this at the beginning, but type in self. Even though they're confused in a minute because there is no self, we are not indented. So we'll go FN, or we'll go to the beginning of the line and then tab out. And then again to the end, and we'll type in pass, just so that they're all not crying out for us. And now we will highlight these, tab them in, put our cursor on each line, pressing Control, Shift, and Alt. Open parentheses, it should automatically populate them, and it does. And then go pass again. All right, perfect. So now we need our classes that accept our base as their argument. Let's type those in. So class, that's class. There we go. Okay, perfect. So we've got our 2 classes. So you see we've got test attributes, and then we've got test attribute, which is again mirroring the functionality that we have with our 2 classes, because we have attributes and attribute. We've got about 54, 55 tests here. If we remove the init, which we are, and we're essentially going to test the attributes and the attribute condition setup in here, because essentially all the functionality, it makes sense. We're going to be using it from the left shift, right shift, greater than, less than, plus, minus, all of the different functionality we have. But what we're going to be doing through that is kind of by default testing these setups over here. So we're probably actually going to, I'd say, delete these. You can write tests for these if you'd like separately, But to save us a little bit of time, we're going to remove these because we're actually going to be testing their test case scenarios through the operators that we're going to use. So we'll remove these test cases. And we might actually separate out a little bit because we've got functionality down here. So let's do that. And then we've got, what have we got? Got comparison operators. Let's and then give a little space for our arithmetic operators as well. And then we'll add in our divider. Okay, so let's copy over this divider. Again, just for human readability more than anything, because obviously we do have a lot of functions here. And if we can at least just put in 2 dividers, it'll make it quite, again, obvious to us whereabouts we are. Okay, functionality, our arithmetic operators, and our comparison operators. Actually, let's put another one in up here because these ones are calling more default functionality, and again these ones are our logical operators. I think they're called logical operators, but these are the operators that we're going to use then to go straight into connect, which will kind of then by proxy test that. Okay, great. So we've got again our structure here. We've got all of our tests. Let's just copy this code over into Maya and just check that this all runs. To clear out our output window at the top, Control V to copy all of our code in, Control A and Control Enter. I'm hoping they all pass because we haven't even got any content in. Great. 42 tests. Wow, I was really off with my count. Oh, that was all the defs we were counting, wasn't it? But then we did just remove a few, of course. So, okay, good. Let's minimize. Let's go back. So test attributes. Let's go ahead and start off with testing the REPA output with our expected result. Okay, so what we're doing here is we are literally just checking that we get attributes. So if we look back again, our REPA that we are using generate string, which is within attributes. But again, when we're actually going to call this, we're going to call it from both. We're actually just test its inheritance as well. We're going to test it from the subclass attribute, and then what we're going to do also is then test it from attributes. So let's add an S there. Let's remove, okay, the rotate X, because that then essentially is using the get atta method or dunder method to pass us over to the attributes class. So we're going to test these 2 ways of getting it here. Let's copy this, go check we get no errors. Attributes, attribute, perfect. What we should be getting with attributes is basically just the node. So here we go, let's remove that. So save, copy. So Control S, Control A, Control C, Control V. And I'll try to not say that too much now because I think you'll probably get it. Let's copy our code in. Press Control A and Control Enter. Perfect. Okay, we've got 2 tests. So essentially a 2 tests to run at the minute. We're going to start highlighting the others out actually just to make sure we don't get too many things that are just showing up. But okay, that's perfect. So first 2 of our tests, first test that we have is running perfectly. Now we need to test the get item and get atta functionality. So let's go for these 2 items. Okay, perfect. So within our get item, we are essentially checking or using the indexing functionality to hijack it past strings that we are going to then be checking for as attribute items or as, sorry, attributes. And what we're going to test here is for the expected result of sphere name and the rotate X of that. So what we want to be able to do is test that our string comes out the same. But we can type rotate X in a few different ways. So let's type also rotate X. And X needs to be uppercase. And let's make sure that both of these actually come through in the expected way. Okay, now let's copy this code out and do pretty much the same thing for our get atta, which again now, and what we can do is just go down here and press dot rx and then remove the get item open brackets. So we should be able to say string. So sphere dot attribute dot rotate x, and then the expected results should essentially mean that it is showing us the group that it is in, the item, the sphere name, and then rotate x. And remember, sphere name can be populated into both of these items using the index 0, because I'm saying, well, first item that we get in these positional arguments can just go straight here. But okay, let's copy all this code over and just test if this works before we move on. Let's clear out our window at the top. Control A, Control V, Control Enter, and 39 tests ran probably. There aren't 39 tests there, but I think it's remembering the history of what we were looking at. All right, that is funny how it does that. It's more of a Maya issue, not a Python issue, because you wouldn't get that if you were running, say, Django tests, or if you're just running Python tests within the attribute, or within our IDE. But okay, these are all working perfectly. That's exactly what I want to see. And you'll see here within the outliner, I've essentially DAG objects only I've unticked, just so that I can see later on when we're creating nodes and attaching attributes that we're also making sure we delete those nodes. Great, let's jump back over and let's uncomment out this code, pressing Control / delete parse by pressing Control Shift Alt, and then clicking on each item. And now let's check an attributes list. Now this is going to be a bit annoying to check, but we're going to essentially probably just cheat it a little bit because the lists are very long that we get. So what we will do, I'll give you a little example. Let's jump over to Maya and I'll show you what I mean. Okay, so let's essentially what I'm doing here is just copying a bit of our code. I'm using the sphere geo, creating a sphere from it, and now what we're going to do is say sphere dot attributes dot list and see what we get. What's about method? My mistake. Of course it is, because we're running Maya commands, aren't we? So we're running functionality. And we're returning back all of our attributes. But here we've got a list that just does keep on going. Now let's have a little look. How long is that list then? That is 229 items long. Now, I don't know about you, I don't really want to copy all of that text in. So what we're going to do is just check that caching and message are in there, okay? Because that will essentially give us a pretty good idea whether all of those attributes, or whether we have a list of all of those attributes. And what we can do is also just check the length. So we can check the length is over 200. So we'll check message and caching. And that length is over 200. We kind of know that. We've just run a test. We've just seen it with the when we're creating a sphere. Now that might change in the future if Maya is optimized in any way, but unlikely that it'll be optimized to change those items. So let's go through and see how we can do it. So expected result, we will put here. Actually put these in a list. That might be a nice easy way to do it. We will make sure. So here's the code that we have here for test list. We're going to give our expected result as message and caching, with our expected result length as over 200 essentially. And we're going to assert these with first equal. And we're going to quickly go through our sphere, attributes list. And then we're going to say that the first item's atta, if we click through, atta just returns attribute. And attribute is essentially the string item that has been gathered. Take us back. Take it back for good. Good song. But essentially we're passing through the string item that we are gathering here through to attribute, and that is what is being used. And we're asserting that those two are the same. And then we're going to assert greater. We're going to assert that the length of this list is greater than 200. Because if it's not, it's probably something gone wrong. Okay, great. So list is essentially working. And what you can do is also maybe add an attribute yourself and then check that the last item in the attribute, because that will be new on that list, will be our new item. So we'll have a look at that in a minute and we'll see if that works. Let's copy and all this code over, jump over to Maya, and then press all Control and Control V, and then Control A and enter. 42 tests ran perfectly, no errors. Let's just check that there is an error popping up. So if we do get something wrong. Nope, yeah, there we go, we got an error. Cool, one failure, perfect. So let's put that back. Well, that's not been changed in our code here. Okay, cool, let's test attribute add now. Okay, and here is the code that we're going to use. So we're just testing that we can add an attribute now. So we're using the default myCommands arguments with our keywords parser, but we're going to create an attribute that has a minimum 0, max 12, default of 9, and it's keyable 1, so we can see it essentially. If it's not keyable, then it'll actually just create it without the channel box, without being visible in the channel box. But what we're doing to first is we're actually going to assert that the item does not exist because we haven't created this yet. So this is our attribute that we're going to create. We are then saying self.sphere.attribute .add, and then we are going to add that name there. So we see we've got them here. Now we're going to assert true because we are actually going to assert again that the item now exists. And then we're going to delete the attr. So again, kind of testing delete as well. And we are going to then assert that it exists again. So what we can do is actually just say, well, we're checking a few things here. Let's cut down our test today because you can't keep this as a separate test, but we are going to be running quite a long tutorial otherwise. So let's do add. We're going to check add. We're going to check exists. And we're going to go underscore delete as well because we're deleting the attr and then checking that. So we are kind of asserting a few different things here. Now let's cycle through and let's have a quick look at where we have exists. Delete that because we're checking it. Delete that. Sorry, delete the delete test delete attributes because we're again checking that. Perfect. I'm going to a few let's test for us to kind of write where we're just duplicating overhead. All right, perfect. So we've got that functionality all working. Now let's test 0 attributes. Perfect. So what we're doing here is we're asserting again that our sphere has the rotate X value as 1, which we jump up to sphere by pressing Control and click. We already know because we actually cycled through all the attributes and we've set them to 1. So we should be able to assert that they are 1 here, which is again kind of testing our get and set. But we're going to keep separate tests for those because these are quite important to check as they're kind of a bread and butter essentially of this. Whereas exist as it is, well, it is, but we also can kind of say that it is true here, but we'll just do a few. So let's run all these tests now, and then we've tested our first class. Six tests ran, and they've all passed. Perfect, all dots. I reloaded my Maya in case you're wondering why it now says 6 tests, because I was getting annoyed with the 42 tests. But here we go. Now let's open up our test class attribute and start working on the next section. Okay, let's do our first set of tests here. Get them all on the next line. And now let's test out the string functionality and the repo. I mean, the repo, we could actually just probably steal that code over because we are testing it otherwise twice, which is a little bit crazy. Okay, let's go and just press Control X, copy that code out, highlight the pass. Make sure we don't have pass in, because otherwise if we have pass here, we're essentially saying pass this code. So all this code is now sort of outside of a function, essentially. It's like having a return here. Yeah, returns us out the function. This code is now no longer in the function. Okay, perfect. So let's now do our attribute, test attribute string. So the return that we get from the standard method of string, if we encapsulate something. Now, I would say that this string functionality is basically the same as what we're doing again up here within get item. What we're doing is we're checking that get item has essentially created us the attribute. So what we're doing is we're passing it back and asserting that by checking the string. So what we can do is just steal that code out so that our string is working correctly. Because what we probably should be checking above is maybe if they're actually passing back a class. So what we're saying here is get item. But what we can assert is that is instance. What we will do is check that that is an instance of attributes. So what we'll do up here is actually we'll import from Nodal. We'll also import attribute and attributes, or yeah, other way around. So what we're actually going to do here is check that when we are running our get item, that what we're doing is then creating an attribute. So we're going to say, well, is instance this item an attribute? We're going to check that against the attribute that we've imported up here. Okay, and now below, which again, we don't really need to do with attributes, so we'll remove that. We don't need to import that. And what we can do is then copy this and then check that that string is actually correct down here. Because we want to actually check that this string output is doing what we set up there down here. And now let's go back up to the get item and get atta. Let's make sure that they are both aligned. So let's press enter. Now we're going to do the same thing right here with the attribute. And do the exact same way. So both of these accessing ways, so we've either got the open brackets with get item or the get atta method with a dot notation, and both of these should return an instance of attribute. Okay, great, perfect. Test that in a second. And now we've got our string check, our repr check, and in a minute we will check our left shift and right shift. But let's just say for the moment, control, we don't need it. So control A, control C, jump over to Maya. Okay, let's open up, press Control A, Control V, and Control and Enter. 8 tests ran perfectly. Great. Okay, let's press Control A, Control V, Control A, Control Enter. 8 tests ran perfectly. Great. Okay, perfect. Let's quickly have a little look at these left shift, right shift. Okay, so we now have our left shift and right shift operators, and what we're using these to do is to connect attributes together. So we've got plain, which if we remember what our settings are, plain, the attributes are on 0, and sphere, they're on 1, and on cube, they're all on 2, all of the attributes up here. So what we're going to do is we're going to assert that we have plugged cube tx. You could say that was actually tx. Do everything is just tx in here. Tx. Okay, we'll do everything as tx. Perfect. We're going to make sure that we essentially have all of the tx's plugged in. Okay, to the the cube tx plugged into the plain tx, which then should essentially be 2. So we should actually have to put here. Let's dot get. We will assert that these are 2 and 1, because sphere, the default is 1, and with cube it's 2. So let's do that. Let's all copy and assert. Okay, let's jump over to Maya and let's test that. Control V, Control Enter. 10 tests ran okay. Now let's check that it also fails. Let's assert equal, assert not equal, just to make sure that we're not just getting any default information back. Open up Maya. 10 tests ran okay, perfect. Yeah, so we're making sure that we've got the right value in there. We could also even assert just at the beginning, before anything's been connected, assert equal that plain tx get is actually 0, because we know that's what it should be. So we'll assert that when it's being created. Let's run it again. Yep, 10 tests run. Okay, perfect. All right, let's jump back to PyCharm and continue writing our tests. Okay, great. Let's go through our comparison operators now. Again, we can check these variables out within our function. Set condition like that will be checked again within our operators, just to keep it a bit more obvious. Okay, let's start going through these tests. So we've got equal. We want to check something is now equal. Let's have a quick look at this. Okay, we've got our test for our first, let's call it equality operator, but we're essentially using it as a comparison within Maya. So our comparison operator will be used to compare two items' values against each other. And it's a good way as well of testing essentially the functionality that we have. Not testing it, but also giving an example of how we use the code. So what we're doing here is we're actually going to say, well, is the cube attribute scale x the same as the sphere attribute scale x? And then we do that with just this code here, rather than 30 lines checking, running the node, creating the node, setting the attributes. We're doing that all in the background. And what we're going to do here is also go through and then check the name. So we know that we're doing CD for the name condition. We're going to essentially check that the name has come through in the way that we have stated it to. As I said with the naming, why we can just remove that. We're going to check that outColor is the attr that is provided back to us from the calc node. So this should essentially be the output from creating this node, which we know is outColor, because it's a it's a child item. And if it was a parent item, we should then get outColor like that. We are going to then do a calc.get. So on outColor, which is 0, which is essentially giving us back the default, because true is set to 0 for some reason, and false is set to 1 within condition nodes when they're created. And then we're going to check the first term. The connection input full path is the same as scale x, because the first term essentially that we're going through is going to be set by cube. Second term set by sphere. So we're checking that the input connection full path, we're also checking these values are the same. They should be equal. And then we're going to delete that node. And again, just in the effort of saving us time, I would say you should go and write these tests yourself. But I'm going to get rid of these. So we are also, what am I doing? Input, yes, I am doing input, perfect. Okay, we're going to start removing tests out just because I'm again worried about time that we're going to take on all these tests. But great, there we go. We're checking that we are able to add a child item within our equality or within our equals operator. Great. Okay, now let's do if not equal. Actually, before we do that, let's actually do the case, do a few more cases, and then we will probably do a light check on some of the other nodes. Because again, we know we're using all the same methodology. We'll just check that the nodes work. But let's also check a parent item. So we're checking child here. So we'll go equality child. So we're doing a child attr. Now let's essentially copy all this. And then below, we're going to save this out as parent. Okay, so here we have our equality operator for the parent attribute. What we're doing is we're now going to, again, plug in the cube scale to the sphere scale, we're going to check what their values are. So they're essentially the addition of those items. So all of the scale will be then plugged into the first term. The addition of the scale will be plugged into the second term to check they're equal. And the expected result for the first test, so we should probably put those together, make it a little bit nice to read, will be that we're checking that we're getting a condition node back from the calc. Okay, then we're asserting true that the first term, if we get, is 3. The second term we get is 3 as well. Okay, which is perfect. And I suppose we probably should actually assert we're getting the correct term. So let's get the operation. Actually, let's go through and check equal. Let's have a quick look within Maya. Go to node editor, tab condition. What we can see is that the default is equal, so we don't need to set that. Delete that because that might throw off some of our setup. So we'll change that to 0. That should be the first index item, so 0. Now we'll press Control A, Control C, jump over to Maya, Control A, Control V, Control Enter. 12 tests ran perfectly. Good to see. Okay, and just thinking, we're going to test one more scenario because we do also have the set condition. So we are actually going to go and copy out and do another one. And we're actually going to just test equality set condition. Okay, perfect. So we have now created our equality set condition test, but we're actually probably just not so much as testing equality here. We're more testing now the set condition functionality. So we're going to now test scale x against scale x with the cube and the sphere. And then we are going to essentially, let's put this up here, because we can do this all in one line, and so we might as well test that. So what we're being returned is, again, the set condition. We're being returned the object, an object attribute, which we can then again hijack to go back to set condition. We're going to again set if true 1, if false 0 within our condition node. So we're testing that these are equal. So if these are equal, we should get 1. Okay, both scales are still set to 1. We haven't changed those, so they should basically be at 1. Okay, and what we can do is actually just check the default. So we won't check that because that'll put them back to being default. But what we can do is assert equal. And what we should be getting from the calc node, okay, that is giving us the condition. So this is the condition attribute, the output. This is the condition node, the attribute outColor R get, and it should be 1 because, again, these are as default both set to 1. So the default output originally should be 1. Okay, and then what we are testing is that scale x, when we set it to 0, would essentially cause us to get the response false, because again, we're looking at R, at outColor R. And then we are going to set the cube SX to 3, and we're again going to have a check and check that the calc node, okay, outColor get, and again, that should be 0 because they still will not be equal. So let's have a quick look at this, and then we're going to delete the calc node. Perfect. Okay, let's press save. I think that logic is correct, but I think we'll be corrected quite quickly from the testing. If it's not, let's open up Maya, press Control A, Control V, Control A, Control Enter, run our tests, and ooh, we failed. We got an error. Good. All right, what have we got here? Value error. This node already exists. Okay, so we know where we're getting this code from. This is from our DAG or our depnode base, because obviously DAG inherits depnode, but from depnode, yep, it's saying 1 line 60. And create, we are creating the node that we shouldn't be. Well, and I think I know where we're looking at here, because I removed a bit of code when we were looking at this, didn't I? So let's go back to depnode and the initiate. And within node type, if we pass a node type, which we are doing as default when we, let's go back to test attributes. So in test attributes, when we do set condition, let's go to set condition. Let's chase our stack. We are essentially passing condition, okay, self.node. All right, so now if we jump through to condition, and we then initiate, we're initiating the class, and we're actually saying as default, create a condition. We're passing a condition through to the depnode initiate. So if we jump now through to depnode, we can see that if we pass a node type, we are going to try and create a new node. But if we already have that node, we're going to get through our error saying this node already exists, you plank. So don't do it. Okay, so now what we just need to do is put in our code again. It says and not self dot say exist. Yeah, we'll just go with self.exist because it was already initiated, so self.exists. And this will essentially check that the item doesn't exist and or doesn't exist first before trying to create something. So that will save us that error coming through, because essentially that is kind of what we want. We don't want to be able to pass something that then just creates another node. So that is probably best practice within our dep node. We can always hijack the functionality and do create and try and create something that does exist. But again, we'll get this error popping up. So it's we do have at least then 2 checks for it, which we probably should leave in. Perfect. Now we'll have to reload Maya. So let's reopen Maya. Let's close your instance of Maya, I should say, and then reopen. Let's press save and then jump back through to our test. Okay, and that's good. So we found a bug already, and that was because we were trying to set condition, and set condition was again accessing the condition class, which was calling an instance of dep node and trying to then create the node for itself. But we don't want to do that. So let's open up our Maya and test again. Okay. Oh, no errors. Beautiful. Okay, 13, lucky number. Great. All right. Okay, perfect. So again, and all of our test cases here are passed as well. So we tested actually core functionality by just running the script itself to see if it ran, and it didn't run. And okay, and it's nice because it's in a controlled environment where we're cycling through all of the conditions in a nice kind of procedural manner, which again gives us a very logical approach to how to run our tests. If we just go through and then after creating the class, we go and run a bunch of code and we just say, oh, this is cool, we'll do this as an example and we'll do that. What we're not doing is actually running through all of the test cases, and we're not checking that all the functionality works, or we're not checking logical or syntax errors. We're just checking that, you know, a few examples run and that it looks cool. But what we're doing here is procedurally running through every class that is that we're going to be accessing, and then we're testing it. Okay, cool. Now let's do the same for these classes down here. But at the minute, but for these, we're actually only going to test one. We already know now that parent works. We're testing parent attribute. We're testing child attribute. So what we're going to do is we're going to copy down a little bit of the code. We'll even cut this down because we know that what we're getting back is being affirmed by the child attribute. Let's unhighlight the not equal operator, the operator test. Let's put in the exclamation mark for not equal. Now we know that this is going to be correct. Calc get. So we're getting the output. So it should again. And what we're going to be getting there is essentially 0. Remember, 0 and 1 are annoyingly the wrong way kind of round, or what logically feels the wrong way around. True is set to 0 as default when you create a new node. We jump into Maya. Let's open up our window. Node editor, tab, condition. So true is set to 0, false is set to 1. There must be a reason somebody did this, but for the life of me, I can't figure out why. Okay, so that is something that we can essentially assert. So the output R essentially is saying, well, what are we going to get back here? Let's see, we've plugged both these in, first term, second term, and we're checking that they're not equal. So it'll actually be true, and by true, we're going to get 0 within our output. So let's test that. And then we can just test that the inputs are the same for the first term. The calc node being cube, second term being sphere. All right, that's perfect. Let's run that test and then we'll see if that keeps on working. We will again go through and copy to our other classes. Ooh, 1 failure. 1 does not equal 0. Of course it doesn't, after all of that explanation. Oh, and of course, sorry, my brain just flipped everything around. So we're essentially just checking that these items are not equal. And obviously that is false. So false is 1. Yeah, that's what gets confusing. You start flipping logic together in some areas and you end up flipping it around in your own head. I'm sorry for my incredibly poor language there of flipping. God, it feels so like a good F. Although the vowels, I think, are the offensive parts of the swear word, aren't they? What am I doing? Okay, let's open up Maya. And then let's go in and test that again. Forwarding test ran. Okay, perfect. All right, now let's, oh, let's not close. Let's unhighlight all of these, and then let's copy our code over. Okay, so we've copied the code over. Now let's go back up to not equals. That was our last one. Now we're going greater than, so we're going to remove that and go greater than or equal, less than or equal. Okay, and now let's go through our cases just to check that they are the right logic. So we are first checking that scale x, these are both going to come through their default values of 1, and these are saying that, well, is scale x greater than scale y? Or scale x is greater than scale x within sphere and cube, and it's not, they're both equal. So this is going to come back as false, being 1. Is it greater than or equal to? No, so it's going to be false, which false is 0 in the default creation of the node. So sorry. We could flip this and put the set condition in, but we're on a roll, so let's go with it. Okay, is x and x of these, is it less than? No, that's false. So that's false is going to give us the 1 within the condition node build. And now is it less than or equal to? Less than or equal to. So that will give us true. Save, copy over, let's open up Maya, run again. 18 tests ran in 0.2 seconds. It's amazing. We ran one class earlier and the test ran in half a second. Now we've got more tests and it's running in less time. I can't figure out Maya sometimes. Python's a little bit more consistent when you're just running Python functionality that it computes on your computer using your processors. But when you're processing through Maya, for some reason, I think it's just doing other tasks a lot of the time. Okay, great. Let's go now through to our arithmetic operators. We are flying through. Great, but we are also over an hour and a half in this video. At the point, sorry, I'm recording, I'm going to try and edit this down, obviously, so I will try to sort that out for you when I edit. So just copy what I'm doing. We're essentially uncommenting everything, and then we are going to get ready to start testing functionality within here. Okay, I've written some tests here, and these are by no means exhaustive. They don't take into account every aspect. I mean, it would take a lot longer to do those kind of tests, and I think that's why I'm probably going to actually leave it to you guys to maybe write some tests, and feel free to send them to me, and I'll critique them, give you a bit of information back on what you could do better. But we're just going to test the base and very basic functionality of these. And if you'll notice, I've left in div, but I've taken out true div. Because essentially what we're going to be doing is whichever Maya you're in, you'll be testing the divide here. So as long as it's giving you back the correct information, that's good. But so what we're doing to start with, we're testing that they add together, and then we're actually going to test that a sphere and cube add together with the translate x. And then we're going to plug that into the plane, translate x. And so we've got sphere, which is 1, and cube, which is all set to 2. And so these will add together to make 3. And now we're going to do the same thing, but minus. So we're going to do 1 minus 2 equals minus 1. And the same with times. Okay, but with cube, we're going to do cube times cube, because we're going to do 2 times 2 to get 4. Otherwise, 2 times 1 is just a bit dull. Let's live on the edge. Hey. Let's go to div. So now we've got divide. So we're going to go for sphere, which is 1. Sphere translate x, which is 1, and then we're going to go to cube translate x, which is 2. So we're going to divide 1 by 2, which gives us 0.5. And now for the power, we're going to set sphere and plane translate x to 3, both respectively. And then we're going to times them both, or sorry, do a power operation on these and plug that into plane. And that gives us 9. Okay, great. Let's test all these. Let's press save. Control A, Control C, open up Maya, and then Control V. So Control A, Control V, and then Control All, and Enter. And we get 23 tests ran in 0.3 seconds. Amazing. Okay, that's awesome. So all the functionality is working the same. But for example, what you could do to add to these tests, essentially, you could add some different numbers. You could add some different attributes. Essentially, check that when you scroll them up, down, that they change as you're working through them. you could also go through and you could check maybe parents or children as well and see how they are adding in. Okay, there's quite a lot of tests that we can do going through these, but at the minute, I'm just trying to get through these tests actually because we've still got quite a lot of things to get through. But the next section should be relatively easy. So let's quickly buzz through this. Okay, so what we're looking at here. Okay, perfect. So what we've got here is our attribute is parent and attribute is child. We're going to test against these to make sure that is parent is coming through true, and that the child essentially is coming through false. So if we're checking is parent in both instances, we should get true for one, false for the other. Because rotate x is not a child, so we'll get false. But rotate is a parent, so we should get true. And the same for child. So we're checking two instances of child with the rotate x, which will affirm true, and the rotate, which will confirm false. Perfect. Okay, now let's go through and do our attribute properties, which again should just give us the string back of the property passed. And then we will also do the path items. Okay, so let's assert true. Actually, assert equal. Let's change that. Let's assert equal, and let's also remove the equality operator and do a comma. Let's assert equal that we are getting sx from .atta and scale x from .atta and shear xy from .atta. Okay, these now should be able to nicely copy these over, and then all we need to do is select the atta or the dot notation atta with Control Shift Alt, and then press and then type in attribute, because we know that these oh, hello, I got it at the end as well. We should also spell that properly. But we know that these are essentially using the same methodology. Oh, attribute model there, that's the one we want. Okay, so we're actually getting both of these from the same thing. So, these should be pretty easy to confirm. Okay, perfect. Now let's get path and full path tests. Okay, so what we're testing here is, again, our path logic. So we're going to test the base DAG node, which again is going to give us just a sphere geo, but then we're also going to test our attribute path, which should give us the sphere geo and the rotate x. So again, nice clear kind of explanation as well when you're coming back to use this in the future. If you look at the test, you can say, okay, where's the test attribute path? And I can look through and I can go, oh, so this is what it's returning. Okay, if these tests pass anyway, I should probably check the test pass before I ever look at this, but yeah, this is the way to do it. And then you've got full path, which again, with sphere.fullPath, we're getting the full path all the way to the geo. But with sphere.fullPath, what we're getting is the name all the way to the attribute. So now let's copy all of that and check that runs. So press Control A, Control C. And then in Maya, press Control A, Control V, Control A, Control Enter. 29 tests ran perfectly. Great. Okay, no errors. Okay, nice. All right, let's jump over to our next set of set, get, and query, which again, we've tested a little bit, but we'll put a few tests in just because we should. Okay, so we've got our set and our test, our get and our set methods here for testing them. And for set, we're essentially going to get the default, which we know the default of sphere rotate x is 1. So we're going to then set it to 2 and then assert that when we get it, it's equaling 2. And then with get, we are essentially just going to check sphere and cube for the default arguments that we gave to them. All right, let's also test actually that we have a fail point, that we have some issue that happens essentially. Okay, so let's have a little look here. We've extended this actually a little bit, and what we're going to add is a few tests to check some scenarios. So we've got one scenario where we might say sphere.set, and we kind of know that that's an attribute error. Even PyCharm is able to figure out that we don't have a set method in sphere, so we're going to check that that raises an attribute error. Okay, so with assert raises attribute error, we're going to run some code and then check that we're raising that error. And now runtime error. So what are we going to go through? We're going to actually try and set a parent with 1 value, which again is a runtime error because we can't set 3 items, essentially 3 children with 1 with one value. Okay, so that will give us a runtime error. And now we're going to get a type error where we're actually going to add an argument to get, where get essentially is just using the get method from my commands, and it doesn't take any argument. So that'll give us a type error because it's expecting it's just expecting self within that argument, but it's going to receive 2 errors back. So let's save, press Control A, Control C, and then we'll run those tests. And there we go, 34 tests ran and with no errors, perfect. Okay, great, let's test these next few items here. Okay, perfect. So now we're testing our attribute query, children, and parent. And with query, again, it's more of a my commands we're testing here. We're testing almost that we're just accessing it correctly. So what we can do is just check a few different different commands, and then check that they're giving us back the information we expect. So if we if we list the children of rotate, what we kind of expect back is rotate X, rotate Y, rotate Z. And then if we say, well, what is the nice name of rotate X? What it's going to give us is rotate X. Okay. What we probably should do again is just assert equal rather than assert true, because we are obviously using the equals operator, and we don't want to get into bad habits that'll then cause us a nuisance. Okay, perfect. So if we list children as well here with the rotate X, obviously there are no children, so we'll return none. Perfect. Okay, and now we're going to test attribute children. So we're going to assert equal first that rotate X doesn't have any children. Rotate X is the child itself, so we'll get back an empty list. And then we're going to assert equal that the rotate function from, the rotate attribute from sphere, and check the children from that, which will give us back the sphere rotate X, Y, and Z. And then the same for parent. We're going to assert equal that the sphere rotate parent essentially won't give us anything back because that is the parent. And then the same with rotate X parent. We're going to check what that gives us back, and it should give us back the rotate because that is the parent attribute. So let's quickly run that and see if that works. Okay, let's press enter. 37 tests ran in 0.6 of a second. Perfect. All right, now we've got our last few. Let's have a quick check now. Okay, let's start with our next few tests here. So we've got the cube translate attributes, which we're going to plug into the sphere translate attributes. And then we're going to assert that the sphere attribute translates are in the cube translate outputs. So we know we are outputting from cube T because sphere T is within that list. And now let's check the connection output. So let's connect the cube translate. Oh, I was actually going to check the rotate there, wasn't I? So let's do rotate. That was my mistake, copying but not checking. Oh no, was I actually? No, I wasn't. Sorry, that was me. We're going to plug cube translate into sphere translate and plane translate. So then what we're going to do is assert equal that all of the translate connection outputs that we've got from cube, that equals, the outputs equal the children of T and the children of, the children of the plane translate and the children of the sphere translate. So we're adding those lists together with all the children. And they're checking that those assert equal. Okay, now we're going to check the connect very quickly because, again, that's being used by Redshift, so we know that that is pretty stable because we've been running it through all of our tests. But we are going to connect the sphere rotate Z to cube rotate X. And then we're going to assert equal that the output is the same as sphere rotate X, okay? And check that that has happened. So now let's check the disconnect. Now for the disconnect, what we're going to do is essentially connect up the rotate X of the sphere to the rotate Z of the cube. All right, so we're going to assert then that they are connected by checking the input of the cube Z and checking that that is equal to the string of rotate X. And then we're going to disconnect that. So now, again, if we try to assert the input connection of cube rotate Z, we should get none. So first we're getting the input, and then we're getting none because we've disconnected it. All right, so like I said, these aren't exhaustive, these tests, but what you can do is, again, go through and see if you can find some more cases. So for disconnect, you could check that with rotate with the parent and the child. So this is checking the child here. But see if you can write another way of doing it, and see if you can write in the exact same methodology, but with rotate and rotate, not or just R, not with the child attributes. Okay, great. We have tested everything here. So let's copy, and then let's jump over to Maya. 41 tests ran, and I've suddenly got, oh, hello, got geo left over. That was not right. Okay, so let's copy all of our test code in, press enter. 41 tests ran in 0.7 seconds without one error. That is good. And that, again, we're not testing as much as we could here, but we're getting, again, a good 300 lines of test code. And we're not being, I'd say we're testing quite well. We're testing every function for at least its core functionality. I think we need to test more edge cases here, test the fail points, but I think I'm going to leave some of that to you. Okay, go through here, like, see again by adding what items you can get an error, essentially. See if you can break the code as well, and then add that as a test. See that you can check for when things are going to go wrong, not just when they're going to go right, and user error as well. So a user may try to set path, or may try to again make a mistake with attr and maybe assert that it use it as a class, but if it's not a class, again, it won't be used. So you've got to try and test all the edge cases as well. But again, I think that this is pretty good for what we need at the minute. I think, for example, my test code for one of my modules of test for attributes is about 1,000 lines long. And I think that most of that code is not just testing, for example, connect. It's actually testing another 7 kind of tests that kind of show why connect's not going to work, why it shouldn't work, what errors it should raise. And I'm affirming certain errors with myself, or just checking certain errors with myself, just to make sure that if a user does try to do something, it'll give a specific error, because it'll be logical and make sense to them, essentially, of what they need to do. Because obviously, like I said, you want to return like I said in previous lectures, you want to be returning, you want to return useful errors. You don't want to return errors that are confusing or don't make any sense, or even worse, catch or do a try catch, not return an error at all, and not have any functionality run. That would be bad, because again, the user will just be confused. Nothing will have happened. And they might write a script with a lot of functionality dependent on something that's just erroring silently. And they might get a long way through before they realize something's really badly broken, but they won't know where the error is, because it'll be essentially a logical error from our side that will not give them any information. So they'll be trying to figure out what's wrong with their code, when actually the code will be all wrong from us, and then screwing them up. But okay, that's amazing. In our next module, we're going to look at dimensions and how we can hijack those, essentially with self.cube.o. So for object, and then we can do, get scale x, get scale y, or get the dimensions of an object, get the maximum unit dimensions within any scene. But thank you so much for listening, and I will speak to you in the next lecture, which we'll do. And I'll speak to you in the next lecture, which will be on examples of how to use our attribute class.